Thank you guys for showing up today and listening to what we have to offer at our business that we started in 2023. We're Northwest Kansas Soil Amendments. I'm Tyler Johnson, for anybody who didn't catch my name coming in, and my business partner is Paul Flanders. We kind of started this out of a need for ourselves when we couldn't quite afford cost inputs in 2023. And we kind of jumped off a cliff and just decided to drop all of our FOSS that first year. We were spending close to $100 an acre on inputs. And so I kind of watched several videos on that and decided this was something I could probably maintain our crop yields with and slowly step away from that. So I'm going to kind of cover a little bit of history on our farm and how I made those decisions and then what we offer after that. So the very first thing I want to cover is the more soil health practices you implement on your farm, the better this is going to do for you. So the more soil armor or soil cover you leave on your fields to keep your fields from heating up and killing off biology, because if the top 2 inches of your soil, if it gets to 130 degrees, which it easily can in July, will kill off all your microbial life. So the more soil cover we have, the better. The less disturbance we make, because every time we make a disturbance pass, we're destroying the homes of that biology that we're trying to get started. And the more diversity you can get out on your fields, whether that's a cover crop or just a better crop rotation, then the more biology and the more different kinds of biology you're going to have on your field. So the extracts that we sell and the biological products we sell will work wherever you're at, but the more of these practices you do, the more results you will see over time. And that's kind of what we've seen on our farm, is the more we've added different products, the less we've worked our ground, the more diversity we've added, the more results we've seen. So this is the first video I watched. If you take a picture of this slide, you can scan that QR code later if you want to watch that video. But it's by Dr. Christine Jones. She's out of Australia, I believe. And she talks about the phosphorus paradox. And what that is that our soils aren't lacking in phosphorus. What they're lacking in is biology. And that's the main takeaway. And it's that 10 to 15% of our applied phosphorus is only taken up by our plants. So that means 90 to 85 of the phos you put out is not used that year, which to me, that's a lot of money I spend to not get into the plant. And of the phosphorus that it uses, 85 to 90% of that is taken up via microbes going in and out of your plant roots. So if you don't have microbiology in the ground and you only are getting 10 to 15% of the phosphorus you put out, that's starting to really trim down how much of that phos that you paid for actually gets into your crop. And then if you're broadcasting it, it only moves 1.5 inches to 2 inches. So if you've put it across the whole field and then you're planting in 30-inch rows, there's even less of it that you're getting. And so she goes on to talk about that the more microbes we have, the better roots we're going to have, the better uptake we have. So I put this picture up there because this is the first year we ran our compost extract in furrow, and it was just at 5 gallons the acre, no other amendments with it, and that was a first-year no-till field. So it's not like it's something that's been 30 years no-till, that's had lots of biology out there. But what we got out of that was those great big roots, and it was a wet spring. That was 2023. So we actually got roots down 18 inches into our soil right through our hard pan, and that's turned into one of our more productive fields because now we aren't growing in a flower pot in the top 4 inches of our field. We started shattering that plow pan, and we've got these great big roots that when they decompose, we get even more water down through those channels, which just keeps this system going more efficiently. So if you pull up your plants and you see nothing but clean white roots, it means you have no biological activity whatsoever in your ground, and you are just having to spoon feed your plants year after year. So if you don't put the nutrients down, they have nothing to grow off of. But if you've got biology there, they can go out and pull nutrients and water in from like 20 to 25 inches away from the plant root, rather than just that 4-inch square around our plants that we see most of the time. And kind of this corn crop ended up making about 75 bushel the acre the time we were done. And I've got more slides on that later. but that was our first year where we cut our phosphorus out. The other thing I wanted to cover was the rhizophagy cycle. It's by Dr. James White. And your main take-homes there are that plants farm the microbes for nutrients in your soil. So the microbes enter the root cell, and this is something they've just kind of discovered in the last 2 or 3 years, is that the microbes will go into your root tips or the root hairs, and then once they're inside, the plant will actually secrete chemicals that strip the cell wall off of your plant and utilize the nitrogen and phosphorus and potassium that the microbes use to build that cell wall, and then they kick that microbe back out through the roots, give it some sugar to keep it alive basically. It rebuilds its cell wall and just repeats that cycle over and over again. And I listened to John Kemp 2 weeks ago out in Burlington, and he said we can provide up to 90% of the nutrients for our plants through this cycle if we just stop screwing with the system by dumping a lot of salt fertilizers in furrow next to the plant. And all those things are disturbances because we dump the salt in there and it kills off the bacteria and the fungi that are right around where we dump that in, and everything has to rebuild itself. So I think that's pretty exciting that we can get away from our nutrient, all the paid for nutrients that we're having to apply and just let the biology do it itself. This is our extractor that we use on our farm. It's made by Core Bio. We can make up to 1,300 gallons of extract an hour. That big red thing on the top is a sand separator, and it goes through that. It then goes through a 30 mesh filter when we pump it out to a trailer into our storage tanks. And then with this model, we've got a recirculation system set up on it. So it's just continually being filtered over and over again and re-extracted, so we get as much of the carbon out of the compost and microbiology out of it and some of the nutrients out of that compost as well. But it looks an awful lot like chocolate milk by the time we get done extracting it. It smells like soil. It doesn't smell like manure or anything like that. I've had several people worried about how this product would smell, but it almost has no smell to it. And it's good for about 3 weeks after we extract it, as long as we don't add any food sources to it. Once you add food sources to it, you've probably got about 5 days to use that up. So generally that's enough to get around a rain delay, or at least since I've been applying it. I say that too many times and I'll get bit in the butt. But yeah, as long as you don't add anything to it, you get about 3 weeks. And so we can do tanker loads that way if anybody's set up for that. And then you can just pull a nurse trailer at a time off of that, add your food to it, go use that in a day, come back and get another load off your tanker. We've had quite a bit of luck with that. So how do we apply this? We've got several different ways. The cheapest way to do it, and kind of the way to get your seeds off to a great start, is as a seed treatment. We apply about 4 ounces of extract to 100 pounds of seed. And that's kind of your rate for corn or milo or something like that. For wheat seed, we can go up to 10 ounces per 100 pounds, just because we're trying to put a lot more grain out there. And we've put even more than that. We went up to a 1/2 ounce per pound when we were doing some oats. We loaded that into a seed tender, and that was wet enough we had water coming out the bottom of the seed tender. But by the time we rolled it once into our customer's truck, it was completely dry. It just freaked me out a lot when I walked up to the seed tender and just watch it rolling out the bottom. And I'm like, well, I wish that was on the plant. But I kind of talked to some guys who do more seed treatment, and they said oats have kind of a waxy coat on them, and so they don't take in a lot of the seed treatment, whereas like a wheat or corn or milo will take in a little bit more. And also when we're doing that seed treatment, it gives us a chance to put on other nutrients for our seeds or other seed treatments, kind of get as much bang for your buck out of that application as you can as the seed's going by. What we've done the most of is in furrow. We run between 5 gallons to 8 gallons an acre. And then we can add molasses to that, or a kelp, or other carbon sources. We've run a humic with it. We've run a fulvic with it. This year I'm going to kind of run a product from Tiva that is both a humic, a fulvic, and another kind of carbon that I can't think of off the top of my head. Should have put that in my notes. But all those things added together really get your seed off to a good start because it's right in the seed trench for you. And then we're going to run some trials this year doing foliar passes. We ran a few last year. We put some on some wheat. So we're excited to see how that goes. We also added some to some triticale and saw really good results with that over the winter, grazing that out. We did that at 5 gallons the acre plus a little molasses. We saw really good green up. And when did we do that, Paul? Like November? October? I think it was October. And so we saw really good green up and growth in those trials right up till we had a freeze there at the end of October. We also want to do some trials for some residue breakdown. We wanted to get them out there this fall, but harvest drug on for everybody, so it was way too cold to get my sprayer out and run this at that time. But we really have seen great results in the seed treatment and the in-furrow treatment. Here are some of those initial results we saw. Here are some oats that I put this out on in 2023. This was in furrow at 5 gallons the acre. So over here is our untreated, no extract section of the field, and this is where we ran our extracts. You can see we got about 2 to 3 times the amount of root mass there, and we saw that in about 75% of the oats that we put out, and that's another field that was I think it was probably second year no-till. So this can work in any kind of situation. And then we also saw a lot more leaf growth there, and by the time we terminated those oats, because it was just in a cover crop, we were about 4 inches taller there than we were in the untreated area. So if you're looking for tonnage, you're going to get more back there, and you should have something that's maybe a little more nutrient dense. I show this picture every time I speak. It's the first earthworm I found on our farm, and for as much digging in the dirt as I did as a kid, when I was out with my dad, I never found any earthworms. And then the first time we applied this, it was right underneath that plant, eating the microbes and the sugar that those plants were putting out. And then to show that this works not just in farm fields, but kind of in greenhouse setting, Paul bought those lilac bushes. This last spring, he put, I don't know, like a gallon of extract on the one, put a gallon of water on the other one. You can see we got 8 to 12 inches of growth on that lilac bush over what, probably 2 months, a month? Basically put them against the side of the house and forgot about them, and then walked by and he goes, "Hey, check this out." And so I think that's pretty promising that you can see, those were grown in the exact same containers or the exact same growing material. We just added the extract to one, and how much more nutrients and everything that plant pulled out of that little bit of soil than the other one did. Here's some of the other results. This one here, I guess this will be your left, is one we saw this year. And what we attribute that to is the BioCoat Gold that we sell from AEA and the seed flare. And that got explained to me, again, by John Kempf 2 weeks ago. And what's happening there is our seeds can actually push sugars out through the roots before they ever get leaves above ground to start photosynthesizing and making the sugar, because it has all the nutrients it needs, plus it's got a biological inoculant right there. So it's feeding all the biology that was in the seed that we put on there as a treatment and what was in the seed trench, because it knows it's got those little bit of microbes on the seed, that it knows it's got enough to get that up above ground and get a head start on it. And here are 2 pictures comparing in 2024. This is my corn versus my neighbor's. And that's just, my neighbor had a full synthetic program, put dry fertilizer out in the spring, came back, ran 1034-0 in furrow, and came back and just kind of your traditional pass. And he was about 2 to 3 weeks ahead of me as far as planting. And so this is about, 2 weeks after I planted. You can see I've already got my roots colonized. I don't have as much above ground mass, but about 3 weeks after I took this picture, I caught him, and our plants were, exactly the same at that point, and we yielded the exact same. And I can tell you, we spent a lot less money than he did. So another way I kind of realized I had enough in-ground nutrients to pull out my phos and kind of step away from my synthetics is by pulling a Haney test. So they give you a soil health score, and that's kind of nice to track your soils year over year as to if you're moving in the right direction or not. But what I really like is it gives you a better idea of your nutrient availability with the biology in your ground. So it measures how much biological activity you have in your ground by measuring the CO2 release in your ground. And that just says how much biology is breathing and moving and reproducing. And based on that, plus how much carbon you have in your ground, they can say, okay, you're going to get this many more pounds of nutrient or nitrogen versus a traditional soil health test. Or not soil health test, soil sample. Anyway, and this QR code is Lance Gunderson talking about the Haney test for about an hour, and he goes through every single box on the Haney test, and I use that every year because this is what a Haney test looks like. It's overwhelming to me when I first got it back, especially when my guy at Nutrien showed it to me, and he goes, "Here you go," and I go, "Cool, what does this tell us?" He goes, "I don't know. I've never pulled one of these before." So I'll kind of try to break this down to the highlights. One, it tells you the total available in. And this was pulled on one of my fields last year that's been no-till about 7 years and had 3 years of compost extract plus some carbon in furrow. So that was how I kind of decided, yeah, I don't have to apply any nitrogen this year. Figured I could probably grow my APH from my farm on 95 pounds of N. And then also it showed me the amount of phosphorus I have available at 58.3 pounds an acre. And since I've stopped applying phosphorus and using biology, my phosphorus levels have gone up every single year on these tests. So the first year I pulled these in 2023, I had about 30 to 40 pounds of phos available, which I think that's pretty interesting that I haven't applied any and yet the levels keep going up. And then here's that soil health score breakdown. Here's our respiration, and that's another thing that's kind of good against your other fields, against year over year on your farm. Don't try to take it somewhere else to somebody who's doing a whole bunch of different practices, because you could go and compare to somebody in eastern Kansas, and they might be 200, 300 parts per million of CO2 respiration. And it's just going to make you depressed because it takes us longer to improve soil health out here because we don't have the rain. Then you've got your organic carbon and percent MAC, and I don't exactly know how to explain those, but that's why that other link's on there, because they do a great job of going through that. And then your carbon to nitrogen rate, and then they give you a soil health score. This is the highest soil health score I have on my farm, and it kind of showed out this year for how that field did. The other thing I pulled is a total digestion test, and that tells you what your entire bank account is in your field, available and unavailable nutrients in your ground. And it's just kind of a benchmark year over year. It's something I want to pull maybe every 5 to 10 years just to see if I'm mining my soils, if they're getting better. It just gave me an idea of what I had available, because right here it tells me the total phos and nitrogen in my ground in generic pounds of fertilizer that everybody's familiar with using. And so what it's telling me there, based on my historic rates, is I've got enough phos and nitrogen for 30 years if I don't ever apply any. And so that kind of gave me the ability to step away from the synthetic input train tracks and work on this compost instead. And the other thing it did show me was my zinc and sulfur are really low. And so that is something I still apply. But kind of here's our results. In 2022, I spent $100 an acre and had 100% drought. So I did not get much bang for my buck on that. And that's where I really took a hard look at how much I was spending and realized I couldn't keep on that thought path because I was going to go broke in a hurry. So 2023, we pulled all our phos and went to compost extract in furrow. We pulled our nitrogen back 20 pounds, and we finished that year 45 days with no rain. Our corn ended up averaging 60 bushel the acre with some hail and 55 bushel the acre on our milo. Our wheat got a similar treatment. We just ran the extract at drilling and then came back with some Black Max 22 from Nutrien in 20 pounds of N in the spring. And what that showed me was I could raise my APH while cutting our inputs back. And so I kind of doubled down on that in 24. We added molasses and a fulvic in furrow. Still kept our nitrogen right about the same, but we had about a 50% drought on our farm. We had 8 total inches of rain, and so our corn averaged about 30, and I was really happy I wasn't spending $100 an acre for 30 bushel corn. And then our milo averaged about 38.5. But the one takeaway from that, and that's where I've got this picture, I think is into my cover crop of oats. And I drilled wheat into it, and the wheat didn't come up until February. And I was like, well, I've got about one plant per one seed. And I'm like, that wheat's not going to amount to much. And if it does, I'm going to have really crappy residue afterwards. I'm just going to kill the wheat. I short rated it for insurance, and then I planted milo, where I had lots and lots of residue from the oats, because the oats were a great year. They were this tall the year before. And so I had lots of ground cover. I made 60 bushel milo. I was like, well, that kind of shows how much residue plays into this system. That if I can double my yield in a short rain year with 8 inches of rain, I can really make some moves when I do get more rain. So in 2025, we doubled down even further. I decided I was going to drill all my milo so I could get it canopied faster and I could create more residue. And that paid dividends for us. We doubled our seeding rate. Normally on 30-inch spacing, we were at 32,000 seeds per acre. When I drilled it, I went to 77,000 seeds per acre. I was shooting for 64,000 seeds total germinated, because the seed tag said I had like an 85% germination rate. So I bumped it that extra little bit to end up at 64,000. That left me with 7 inches in between the seeds and 10 inches from row to row. And I was canopied by July 4th. So I saved myself a lot of heat stress by keeping my ground covered. As you guys know, July and August are terrible here for trying to keep crops alive. But what we did was we put 4 ounces of extract on our seeds per 100 pounds. We used the Seed Flare, which is a micronutrient pack, at 2 ounces per 100 pounds. BioCoat Gold at 4 ounces, and that's like a talc or graphite replacement. And it's got lots of biology in with it. And so what that did was give our seeds the biology and the nutrients to start strong and stress-free. And it cost about $2 to $3 an acre. So pretty easy to make that back at harvest time. In furrow, we ran 5 gallons of extract per acre. We ran the blackstrap molasses as a food for our biology. And then being blackstrap molasses, you get some trace minerals with that. That's kind of what makes up for the mess of handling blackstrap molasses, because it's about as difficult as you would think. But that is something we mix in at our facility if you want us to. And then we ran Singular Agronomics fulvic acid at 2 ounces per acre. And we did some trials with dry kelp with a humic at 15 pounds per 1,000 gallons. I didn't really see any return on that. We'll kind of keep track of how that into next year, if it's a delayed response. We're going to run some higher rates of that too, because that was at about 1/4 of the rate that they recommended, because I don't like running full rates of stuff, because I don't like spending money. Yeah, see, and then we did a foliar treatment. This was about July that we ran this. I really wanted to run it in June when we were at about V4 to V6 would have been ideal. Instead, everything was about knee height or taller, because it took me so long to get my planting done. But we ran 2 gallons of melted urea that was made with the humic acid. We got that out of Sterling, Kansas. They delivered us a tanker of that. And then we ran 1/4 gallon of zinc and 1/4 gallon of sulfur from Nutrient, and we let them treat the water and add the extra water. This is the first year I was doing spraying and the first time I was doing foliar. I tried to remove as many variables that I could screw up as possible. So I let them do that. But all in, that was my entire nutrient program for my farm. I spent $40 an acre, which is quite a bit different from where we were at in 2022 at $100 an acre. And this kind of just breaks down what we spent on every product. I'm happy to talk about those in more details later. I bought a cone bottom so that I could have urea brought in, and I figured that into my cost of production. But I was pretty happy at $40 an acre. That's pretty easy to make that back at our crop insurance levels, which is kind of how I figure things out, is I take my crop insurance guarantee and then start working backwards from that. But here's just a little blurb on our BioCoat Gold. Like I said, we apply it at 4 dry ounces per 100 pounds of seed. I use a rave cup as it's going into the seed box. I get it in 5-gallon buckets that weigh 20 pounds. And so we just scoop it out with a rave cup and meter it in, because if you try to put it in the pro box or in your seed tender as it's going up every auger or being dumped into something else, you'll notice it just dusts off into the atmosphere. And there goes money that you spent that's not actually getting into the soil. So as it's going into the seed box is about the best place to get it on there. And it mixes in really good. It's also, like I said, it's a graphite and talc replacement. The things the AEA totes about it is it speeds up germination. And we did see that. We saw our milo germinate in about 7 days this year and pretty consistently. We had really even emergence. And then it builds that robust root system that you saw as soon as that seed put out its first little root. It had biology on it. And the other thing that it supplies is a fungal element that we really lack out here in our soils from years of tillage and chemical passes. The seed flare at 2 to 6 ounces per 100 pounds, it increases your chlorophyll in seedlings, which means you're going to get more sugars pumped into the ground, which means you're going to have more biology around those roots. It's going to increase the size of your reproductive bud associated leaves, which just means more grain per head. And what it kind of contains is magnesium, sulfur, cobalt, copper, manganese, molybdenum, and zinc. And I really liked it because it had zinc in there because I was low on zinc on my soil tests. And at 2 ounces per 100 pounds, it's pretty cheap. Here's our seed treating setup. It does not have to be this complex if you're wanting to treat your own. We've treated it with a little spot sprayer from Tractor Supply, but this allowed us to do a lot of seed treating for customers this year, or this last year. We put everything in this big tank, the seed flare and the extract all together. It's wet when it comes out the bottom. We use some latex gloves when we're treating, and so it's enough to make your glove wet, but by the time we dump it out of the hopper on the other end, it's dry. So you're not worrying about it gumming up in your planter or anything like that. And that's just that's got volume. There we go. You don't need to hear that. But that's just a little video showing it go by in slow motion because I thought it was neat. But you can see that it's not gummy or wet by the time it's coming out, but when you grab it with your hand, it's just enough to cover the seed. To run my foliar passes, I bought an old sprayer. It's a 2012 Apache. That's a 100-foot boom, 1,000-gallon tank, and all I run through there is nutrients and biology. I don't run any herbicide or anything through that. And it was at a price that covered doing the foliar passes versus hiring somebody to do it. But I guess the point of that slide is it doesn't have to be fancy to do these things. You can just get something to just get by with it. This is what my corn looked like on July 15th when I went out to spray it. Like I said, it's a lot bigger than I wanted it to be, but I don't really think at this point that it looked nutrient deficient. What ended up hurting this corn was water. We just ran out of gas to finish. But at this point, it looked really good. We'd just gotten a rain, so I was trying to get some nutrients out there. Here's what my milo looked like. July 7th, it was planted March 21st. This field ended up making 80, and I was really happy with the canopy we had. This is just a different angle. You can see we're basically have the ground covered. I mean, there's still spots there where you can see the ground, but in a lot of those places, I still have residue from the year before. So we're still shading that ground a little bit, but that really helped us out later in the year when we went the whole month of, well, it rained for us the beginning of July and didn't rain again until August, like 10th or 15th, somewhere in there. And we got 5 inches of rain. But this is what my milo started to look like right around my mom's farm, for people who are familiar with that area. I drilled that May 12th. So I tried to get that out early. It got really big and started to burn up. But I was glad I only had about $40 an acre in that. But, caught 5 inches of rain and it turned around. That stuff right there ended up making 75. And some of the other quarters on that same section made 90. This is the latest stuff I planted. It didn't show any of the drought stress. It was a short season milo. It was drilled like June 25th. So right at the end of the insurance date for this. And that made 116. So that's what this system can do when we get enough rain. And we kind of protect ourselves ROI wise by, if it doesn't rain, we don't have a whole lot into the crop. There were 4 passes right down through the middle of this that made 150. And that just kind of gives me some excitement that this system can still go out and ring the bell when we get the moisture without having a lot of nutrients up front, as long as we let the roots do what they do with the microbes in the soil. So here's kind of overall slide of what we saw in 2025. We had 3,000 acres of milo out. Our closer roll rows reduced our heat stress and drought tolerance. We made about 65 bushel the acre average on our farm, which is right at our APH. So I was pretty covered there. 10% of our field made 100, or 10% of our farm made 116, 10% made 19 and 30. So it just kind of depended on what I had for residue the year before and how much rain I got. My takeaways were that I liked spreading out the planting dates. So I didn't have all my eggs in one basket, because I easily could have had all that stuff up front and had it all burn up. I needed to pay closer attention to my maturity dates. So I had one field that had like 10 days longer maturity on my milo than another one, and it ended up only making about 55 because it just didn't have enough time to mature. But on my best field, I raised a bushel of grain for a half a pound of nitrogen. And that's what was in the soil plus what I applied via my urea pass. And I need to do more foliar trials with the N to see if 2 or 3 more passes makes a big difference, or if maybe that 2 gallons the acre was the sweet spot. On my corn, I just learned that rain makes grain. I had 2 fields that were a half a mile apart. One made 62 and the other made 30. There were 2 times I tried to get to the field that made 62 and it was underwater. By the time I got to the other field, it was bone dry. And so I guess my takeaway was I'm glad I didn't have a lot invested in that crop. But here's the Haney test I pulled in the fall, which is not a great time to pull a Haney test because you're dry. I think it had froze once, so our microbes had slowed down, so it's showing less nutrients than if we were going to pull one in the fall after we've had a little bit of moisture and the soil start to warm back up. But this is on that same field at the end of the year that I showed you at the beginning, so 0 to 12 inches, I still have 50 pounds of nitrogen left. I still have 90 pounds of phos left, which is more than what I had at the beginning of the year. So I built phos. And then my soil health score took a hit, and I think that's just because it was drier and we just pulled a crop off. The system hadn't had a chance to recover. And so I talked to Lance Gunderson about this at the end of the year down in Wichita, and he kind of scolded me for pulling these in the fall. He goes, well, when are you going to plant? I'm like, I don't know, middle of May. He goes, well, when's the latest you could pull your soil tests and still get your nutrients applied if you needed to? I'm like, I don't know, middle of April. He goes, well, then pull them in April. He goes, are you pulling these on every field? I said, yeah. He goes, do you make different fertilizer choices on every field? I said, no, I apply the same thing on every field. He goes, well, then stop pulling them on every field. Pull them from, if you got a group of fields, pull them from the most average one of the group, and do that for every group of fields you have. He goes, stop spending so much money with me. And if you're not going to change based on what every soil test says, don't pull them on every field. And by pulling them closer to the growing season, you're going to have a better snapshot of what you'll have available in the spring than if you're going to pull them back in the fall. He goes, I mean, how many months is it between the fall and the spring or when we do stuff? I mean, it's easily 6 months, 5 to 6 months. So why do we care what it looks like in the fall? The reason we pull them in the fall is because that's when the fertilizer companies want to sell us nutrients. And that's when it's going to show the most need, right after we pull a crop off. Here's the yield map from that field that did the best on our farm. And like I said, those dark blue areas were the ones that I'm really excited about. I don't know that we're ever going to see that across the whole field every year, but there's going to be years where it rains and we're going to be able to capture that yield. The other takeaway I have from it is maybe I should stop trying to grow a crop where I drive my semis and my nurse trailers and everything along the end and spending money on that when 7 to 8 years out of 10, I don't grow a crop there because it just burns up on the end rows. If you're going to run our product, recirculating without a filter is great on your nurse trailers. Take the filter out, spin the tank up, turn your motor off, put the filter back in, because the extract will settle in the tank, and you'll plug the filter like 5 or 6 times before you actually get it spun back up. But if you take the filter out and just run it without that and stir it around for, 5-10 minutes, then you don't have a problem. Put the filter back in, push it onto your planter. We really like metering tubes from SurePoint Ag. It'll run through orifices just fine, but I've had absolutely no problems with the metering tubes. Do a really good job of cleaning your systems after you run it if you're going to put them away afterwards, because they will turn into a science experiment. It's a living, growing material, and you will have penicillin and every kind of thing else growing in your tubes and your sprayer and everything else. It's a lot of fun when you find those. I think it kind of smells like toddler vomit is the best thing I can compare it to. It's gross because it's this hose that runs around afterwards that I always forget to rinse out, and then I open it wide open the next time, and somehow it always ends up all over me. And then Paul tells me to go take a shower because I smell awful. If you're going to do the extracting yourself, it adds about an extra hour and a half a day to the process. Like I said, we can make 1,300 gallons in an hour, but you still have to get all the compost out ahead of time. You got to clean up afterwards. It's not just make it and walk away from it. Composting year round, if you want to do that on your own, is kind of challenging. So you can bring in compost from us or other sources if you're wanting to do this on your own. Kind of takes some of the pressure off of making it yourself. And there's a type on here. Running foliar trials without your own equipment is tricky. Trying to convince a third-party sprayer to run a bunch of different products that might not be from their company, or spending time flagging stuff off is hard. So that's kind of why I went to my own sprayer. But that's kind of the long and short of it. If you guys got any questions, I'm happy to answer them. Obviously, I'll be around here, but I think our food's ready if we want to eat. And when we're done eating, we can go out and take a tour of our facility. I can give some directions how to get out there, and we can go look around that. And you guys can call me anytime or email me. I love talking about this. And there's no stupid questions because I've asked them all before learning how to do this. So thank you for your attention and your time. I appreciate it.